This is lesson 11.3, multiplying a polynomial by a monomial. So something that has multiple terms, polynomial by a monomial, one term. All right, so the big idea, to multiply a polynomial by a monomial, you're going to multiply each term of the polynomial by the monomial and then add the products. Very mathy sentence right there, but this is actually very simple. This will be a quick lesson, and we will fly through it and feel good about it, promise. So no definitions. Example number 1, find two equivalent expressions for the area of these rectangles pictured below. So we're looking at the big rectangles here and talking about area. Now we know the area of a rectangle is base times height. Okay, so that's one thing we can do is multiply the base times the height. We've been given some weird things here because our units are x and they're not an actual number, but we'll talk about that. We could also actually just add up everything that we've got here. So first let me explain this, because when you look at this, it might not make a lot of sense. So these are clearly squares because both sides are the same length, labeled x. Whatever x is, it's going to be both the base and the height. Now what is this x squared? That's the area of it. So if it was 5s, okay, this would be 5 squared because it's 5 times 5. So because you're multiplying x times x, I know the area of the square is x squared. Now over here, they tell you that these little side lengths are 1. And we know that this side length right here is equal to this, which is x. So when I find the area of these, it's 1 times x, the base times the height. So 1 times anything is just itself. So we know the area here is just x. So I want to express this two different ways. The area is everything here on the inside. So first, let's talk about the sum of the areas. And the sum would be adding up all of these pieces here. Sum is adding. So the total area is all of this. Now I can't write this as one just like simple thing, one term, because I have x squareds and x's. And we know you can't add those together. They stay separate. But I can count how many x squareds I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10x squared. That would be the area of all of this, plus the area of everything over here. I have 6 x's, so 6x. All right, so if you went and found out, someone told you what x was, you could plug it in for each one of these individual boxes and figure it out, but you also could now just plug it right into this formula here, which represents the sum. We added up all the x squareds, there's 10. We added up all of the x's, there's 6. And those two areas together gives you the total area. Now that's the adding version, but we're used to quick and simple, right? If we know the base and the height, so this distance and this distance, we know the actual numbers, all we have to do is multiply them together to find the area of this space. Base times height, length times width. Well, we do know what this is, right? It's this plus this. Well, what's x plus x? That's 2x. What about all this? Now, we can't put all this together to make one term, but we can combine our x's, x plus x plus x plus x plus x. That length right there is 5x. And this length right here is 3, 1 plus 1 plus 1. So the expression that represents this whole top is 5x plus 3. And the expression that represents this length is 2x. And so if it's length times width to find the area, we would be doing 2x times 5x plus 3. Multiply the length times the width. Now, real quick, jumping back to the title of this section. 2x is a monomial, it's one term. And then 5x plus 3 is a polynomial because it has more than one term. Poly means more than one. Okay, it's actually more specifically a binomial because there's 2. And if there was 3, it'd be a trinomial. But when there's more than one, that's a polynomial. So we look at these are supposed to represent the same thing. This is the area represented as a sum. This is the area represented as a product, or length times width. So if I simplify this, I should get this. And so we're going to distribute here. And this is called multiplying a monomial and a polynomial. And when I multiply 2x and 5x, it's 10. And then think about the x's. When we multiply, the product property says you actually add the exponents, x times x. x to the first times x to the first is x squared. So here's that piece. And 2x times 3 is 6x. So we expressed it differently, but they're equivalent. We just proved that they're equivalent. So let's try it again here on the second one. Start with the sum. Adding up my areas that I have. I know the area of these, each one is x squared, and there's 3 of them, so it's 3x squared. And I know I have 6 of these, 6x's. Now, what about length times width? Base times height. This is 3x, and this is an x plus a different term, than not a like term, so I gotta separate them. I can't put them together, and that's 2. The 1 plus the 1. So this length is 3x, and this length is x plus 2. So my length times width, and you can write it either way you want, but normally you're going to put the monomial first, so 3x, and then in parentheses, x plus 2. And if we go ahead and distribute and multiply, 3x times x is 3x squared. You're adding these exponents or powers of 1. 3x times 2 is 6x. Okay, so we're learning how to do this while applying it to this specific situation. So now that you see how to do that, the bottom should be pretty easy. And I think this lesson will be pretty easy. Just got to make sure you remember all your product rules. So we're just distributing here. So this times this is 6 with the coefficients, x to the first times x to the second. You add those together, that's x to the third. Now, you can multiply an x times a y. You are allowed to do that. You can't add them. You couldn't add 2x plus a y. But you can multiply, and what happens is they just get paired together. You just write it as multiplication. So this part right here, you're going to multiply this. Oh, and I'm looking at this incorrectly. See, I wrote 3 terms here. I wrote 3 products 3 times I'm going to multiply, and that was incorrect. I'm going way too fast. This is one term, right? These are all connected. They're not separated by pluses or minuses. This is one big term. 3x squared y to the third z to the seventh. That's one term. So I am multiplying 2x times this. That's one term. Okay, so the only things that are going to kind of interact or change are the similar things. So 2 times 3 is 6, and x times x squared is x to the third. And these numbers will just tag along. Okay, so technically this was a monomial times a monomial, not a polynomial. Here we see a polynomial because we have these plus signs separating these terms. So this is one term times 3 terms. 2, 3. If there's no plus or minus, like here, that's just one big term. And so you're just multiplying this times this. And any variables that are not similar there will just tag along. All right, so here, now we're going to go one at a time, and we're going to actually create 3 separate terms. It's possible that you could put them together at the end. It's possible that you might not, though. So when I multiply here, whole numbers, it's negative 12. The a's will combine, and the b will tag along. So a squared times a squared. You're adding the 2 and the 2. It's a to the 4th times b. Now, this is a plus, but when I multiply by negative 3 times positive 7 is negative 21. A to the second times a, you're going to add this 1 to the 2, so it's a to the third. There's no b interaction, so the b tags along. And then negative 3 times positive, this is negative 15. A squared times a is a to the third. And again, the b just tags along. And so you would want to check. I have a to the 4th b, a to the third b, a to the third b squared. Those are all different. Okay, the only way you could combine them is if I had another a to the 4th b over here. This almost is that, a to the third b. Now these two almost look like you can put them together because they both have a to the third, but the power of b is different. And so those don't go together either. None of these are like terms. This is a final answer here. All right, last one. Again, look for the separation of terms with the plus or the minus. So I have three things to multiply here. This is a monomial times a trinomial. There are three terms, trinomial. 7 times 2 is 14. X times x to the third, that's a x to the first. So x to the third becomes x to the fourth. And now I do have a y to multiply with this y. So y to the first times y to the first is y to the second. So nothing tags along there. Everything's getting multiplied. 7 times negative 5 is negative 35. X times x is x squared. And y to the first and y to the fifth is y to the sixth. And then my last one. This is really a 1 in front, so 7 times 1 is positive 7. X to the first and x squared is x to the third. Y times y is y squared. All right, so the trick and the one place I could see this messing you up is right where I messed up, is seeing a term here with multiple variables and thinking that they are separate and they would all have to get multiplied by the 2. Okay, but the coefficient to all of these is 3. They don't each have their own individual coefficient, where once they're separated with these plus signs or the minus signs, each grouping of these variables, each term has its own coefficient. All right, so just like everything we do, the more practice, the easier that will get, as this is a little bit new. Now, again, in this last one, you go and make sure that none of these can be put together. I have x to the fourth. Neither one of these are x to the fourth. This one's x to the second. This one's not. So the y's don't even matter. Everything has to match perfectly if you're going to put them together. So we're good.